Okay. Okay. I changed this last y prime into just y, and I hope this would make sense here. So I don't need any of those here. Okay, let's take Laplace transform. This fancy script L is here. Okay, here we go. And then let's work out these t's. What does that mean? That means it's a derivative. Oops. So this is a derivative. And then, and I just change of sign. And this means it's a derivative. And I need sign change here. Okay, let's continue. And this is Laplace transform of y, but taking the derivative, so y of s, but taking the derivative, this is y prime of s in capital. How about this one? Sy minus y of 0. Okay, how about this one? S squared y minus s times y of 0 minus y prime of 0. And then we need further derivative computation. Okay, let's go ahead and do that. Taking the derivative of this constant, that'll disappear. Derivative of this linear function, s times the constant, so only constant will remain. And finally, this one will have to use the product rule. 2s times y plus s squared times y prime. And that'll take care of all the derivatives. Is everything done? Looks good. And y of 0, let's write it a little bit simpler fashion. Why not? As if we have the initial condition. Okay, all right. And then let's work out some manipulation. Let's see. We have negative s squared y prime, negative 9y prime. So that's going to give me negative s squared plus 9 capital Y prime. How about y part? Negative 2sy, positive 2si. So we're going to get just 0. Now how about the constant part? Y 0, so this is minus minus plus y naught. And here, this one is going to be minus negative 2 y naught. Okay. So we are going to get minus y naught, isn't it? Did I do this right? Let's check some algebra. This is the trickiest part, as a matter of fact. Let's consider y prime part. Negative 9, negative s squared. Okay, that's pretty much all set. How about y part? Negative 2s, positive 2s, they cancel each other out. And here, minus y0 or y naught, that becomes plus. And this is -2 y naught, so we get minus y naught. Okay. So flip one to the other, then I'm gonna get equals to y naught. We get that. Y prime is therefore y naught over s squared plus 9. We need this negative sign. Okay, that completes y prime computation, and if you find out its antiderivative, then I'll be able to find out what y is. Y of s is gonna be the antiderivative of this guy. Let's increase the font just a little bit. What's the antiderivative of this? As a matter of fact, this is an arctangent function. It can be manipulated like this. Let's see. Let's begin with this. Divide both numerator and denominator by 9. And 9 divided by 9, so this is going to become 1. And then s squared over 9, we can rewrite it as s over 3 squared here. Okay, I don't need this any longer. And over here, let me see. If I take the derivative of arctangent, so this is gonna be minus of I naught, and arctangent of s over 3 plus some constant. Let's see. Take the antiderivative and this one over that, and by chain rule we have 1/3, but we have 1/9 is here, so I'm gonna get some constant here. I think this is right. Let me check. Arctangent of s over 3 let's see. Yeah, we need 1/3 here, but I have 1/9. Oh, I did it backward. So here should be 1. I'm getting a little bit confused here. Let's do this. 1/3, and then y0. Put everything in there. Okay, calculate it, and then all those y0 over 9 is in the numerator, and the denominator is s squared. Why am I doing that? I can go all the way back over here, and then okay, all right. This is correct antiderivative computation, and detail is left to the students. It's a calculus problem. So we have arctangent. Okay, all right. What kind of function will give you arctangent like this? If I remember correctly, it's gonna be sine of like this kind of thing. Let me see. What page is it in? Yes, this is on page 358. For this computation, let's see. Give or take some sign. Okay, that. So we need some coefficient here. That's not too much of a problem. And then, okay, that. So we need 1/3, 1/3 y0 times this. That's going to be one solution. As for this constant, well, that's going to be different. It's not going to have Laplace transform. By the way, what about this arctangent of 3 over s versus arctangent of s over 3? As a matter of fact, s over 3 plus 3 over s, and then simplify. You're gonna get a constant. Okay, let's do it this way. You see, it's a constant. So arctangent of 3 over s is basically the same as arctangent of s over 3 with some constant in there, which will be absorbed by this k, and that constant is actually pi over 2, excuse me, but I don't want to talk about that. It's too time consuming. Check the textbook. There's a picture in geometry and there's all the explanation there. So we got the solution from Laplace transform and it makes sense. Final checking. Define y of t as 1/3 y0 sine of 3t over t, and then put everything into this differential equation here. T times y double prime of t plus 2y prime of t plus 9t times y of t. Simplify, what do you get? Yes, you're going to get 0. That confirms that this is actually a solution. There gotta be another solution here, but looks like I can't find it through Laplace transformation. That's okay, that's the nature of this business. As a matter of fact, if you go to the page 365, it reads kind of like this. In some cases, you may find 2 independent solutions, and in other cases, you may only find 1 solution. It may be useful to have the following table for quick reference, blah, blah, blah. So the same kind of philosophy applies here.